In this video, we're going to be taking a look at this Creality Ender 7 3D printer, and I want to send a big thank you out to Mech Solutions. That's mechestore.com. There'll be a link in the video description down below. They provided me with this printer to bring this video to you guys. So we're going to go through a basic assembly and setup. We're going to do a very brief review of this video, and I say brief because most of my videos I test the printers extensively, usually for months at a time, before even bringing a video to you guys to tell you all about it, because I want to give you guys a fair and honest review of what I think of these printers. Now in this particular case, it's a little bit different, and I'm going to explain why in the end of the video. And for those of you guys who are already familiar with what an Ender 7 looks like out of the box, you may notice that I've already done a few modifications to this printer. And again, that explanation is going to be at the end of the video, so keep watching through and pay attention right to the end, because I'm going to tell you guys where I'm headed with this thing and why. So let's get started. And so I'm not going to do a full unboxing, but I'll show you guys a few things that the printer comes with. Of course, it comes with an instruction manual, a warranty card, there are some basic tools and zip ties, there are some cable connectors and spare nozzle, USB stick, power cord, a spool holder, a few bits of hardware and a scraper, and finally a roll of white PLA to get you started printing. And so the first part of the assembly that we're going to perform here is attaching the rear pillar of this printer to the base of the printer. Now, this rear pillar is the larger of the 3 aluminum extrusions that are included with this kit, and it's pretty obvious which one it is. Now, you're also going to need to grab 4 of the M5x18 socket head cap screws. They will all have lock washers, but you're going to need to take one of the serrated lock washers out of the hardware bag, and we're going to be putting that serrated lock washer on one of those socket head cap screws, and we're going to be inserting right now the rear pillar into the base of the printer, and we're going to be putting that with the stepper motor facing down. At this point, I would recommend only finger tightening those socket head cap screws and not tightening them all the way down, because this will make it easier to align everything at the end. Now we can attach the remaining 2 extrusions to the base of the printer. I like to call these the side pillars of this printer, and we're going to be using more of those M5x18 socket head cap screws to do this. Now there is no left and right side of these extrusions, but you'll notice that the 2 flanges are different. One side has a button head cap screw sticking up, and that's going to be the top side. So the bottom, without that button head cap screw sticking up, that will be facing down, and again we're going to be using those M5x18 socket head cap screws, and just finger tight for now, attaching those pillars to the base of the printer. With all 3 pillars attached to the base of the printer, I can more easily turn it on its side to access the electronics on the bottom. Now this is not a necessary step in the installation and setup of this printer, but because we are reviewing this printer, I want to show you guys what's under the hood. And so if you ever need to access the control board or any of the electronics in this printer, you would get to them through the bottom. And so there's a panel that covers the bottom of the electronics, and there are a bunch of small M3 button head cap screws that you can just simply undo, and that panel will slip right off. Underneath the printer, it's nice to see that Creality has done a very respectable job in terms of wire management, and the thing that stands out right away are those 2 very large stepper drivers that you can see on the right hand side of this printer. And looking closer at the main board, you can see that the X and Y drivers on the main board are missing, and that just confirms that these 2 here are running the X and Y stepper motors for the CoreXY motion system. What's really cool about this is that there are dip switches where you can play around with the current and micro stepping on these drivers, and so if you had run a custom control board in the future, you really have a lot of flexibility with those drivers on the X and Y stepper motors. Other than that, you can also see the blower fan blowing over the Z and extruder drives on the main board, as well as a ferrite core suppressing high frequency noise on the incoming 24-volt lines. And since we're on the topic of electronics, check the side of your printer to see what your power supply is set to for incoming voltage. I'm in North America, so I had to switch mine over to the 115 setting because it came out of the box set to 230. Back to the assembly, we're going to be installing the print bed onto the Z carriage using 8 of the M4x6 socket head cap screws. This is also a perfect opportunity to take a look at the print bed itself, and see if there are any interesting features that Creality has built into the Ender 7 print bed. Right away when you pick this thing up, you'll notice the heft. It's quite heavy with all that metal bracketry. The heating element is a PCB trace style heating element. And what's nice to see is that the bed clips do not run over those traces like on some other low quality printers. So in this case, they've modified the traces to accommodate those bed clips. So they'll never rub and they'll never short. Now, all of this heavy metal bracketry on the bottom is to prevent this print bed from sagging and to keep it really solid, because it is going to be a cantilevered print bed on the Z carriage. And speaking of the Z carriage, this is where you take those 8 M4x6 socket head cap screws and you attach the print bed to the carriage. Now at this point, I really wouldn't tighten them down too tight just yet. Snug them up so the thing's not flopping around, but don't over tighten them because you may have to make some adjustments later. And while I'm working on that, maybe you should consider subscribing. I think my videos are pretty good. I know I'm a little bit biased, but it's pretty easy to hit that button down below, and it goes a long way to encourage me to bring more content like this to you guys. So please consider subscribing. Now, if you thought 8 of those screws were enough to hold the print bed into place, you're wrong. There's 4 more. So you got 4 more M4x6 socket head cap screws, and those go into the back of the print bed. You'll see on the Z carriage, there's a 90-degree bracket, and these M4x6 socket head cap screws go through that bracket into the print bed. And once you have all of the screws now aligned, you can start tightening them all down. So that's why I recommended with the prior 8 that you didn't tighten them down just yet until you get these ones in. This is not in the instruction manual, but I would recommend checking the 2 button head cap screws that hold the lead screw nut to the Z carriage assembly. And so if you look inside of the rear aluminum extrusion where the lead screw resides, you can see from the top that those 2 button head cap screws are accessible. Make sure they're tight. Mine were loose from the factory, and this would cause a lot of slop and play between the lead screw nut and the Z carriage assembly, which would probably result in a lot of print defects and frustration when I go to use the printer later. Now we can work on the top of the printer, and it attaches to those 3 pillars using more of the M5x18 socket head cap screws. And on the back pillar, one of those socket head cap screws is going to get the serrated washer. And therefore, all you need to do is take the top portion of the printer, carefully place it on top of those 3 aluminum extrusion pillars. Be careful not to knock it over because it isn't bolted down just yet. Take those 4 M5x18 socket head cap screws and lightly tighten them using your hex key. It's a tight area to work within, so you're not going to really be able to get your fingers in there to do it. And don't tighten them down all the way just yet, because there are 8 more M5x18 socket head cap screws attaching the 2 side pillars to the top portion of the printer in the same way that you just attached the rear pillar to the top. And because you followed my advice and you left all of those screws finger tight, you should be able to manipulate the whole assembly such that it's pretty easy to get those final 8 M5 socket head cap screws into the top of the frame. Once they're all in, you can finally tighten them all down. The spool holder is next, and it attaches to the base of the printer using 2 M4x10 screws, and you have to assemble the tube inside of the metal bracket. And that's pretty easy to do. You just take the retaining ring off of the end of the tube, you slip the tube through the metal bracket, and then you twist the retaining ring back on, and you got to twist pretty hard to make sure it doesn't slip back off. But once it's on there and it's not coming off. And now you're ready to fasten that assembly to the base of the printer, and the holes are very easily accessible, so you shouldn't have any trouble with this step. The instruction manual then suggests placing this plastic trim piece over the back rear bracket of the print bed assembly to cover those screws. I suppose this could be useful for preventing pieces of filament and debris falling into that little area back there, but I found this piece to fit very poorly and awkwardly, and so it might be on there for now, but it's coming off pretty soon, as I don't really think it's all that necessary. At this point, we can start making some of our electrical connections, and you can take the heated bed cable and plug that into the connector at the bottom of the base. It's keyed, so you can't plug it in wrong. Just thread that connector on to secure it into place. Then you can take the small JST connector here for the stepper motor and you'll see there's an opening in the base of the printer. Again, this is another keyed connector, so you can only insert it one way. Make that connection, and then grab the large cable and look up to the top of the printer, and you'll see the receptacle for this large connector. It's another keyed connection, so you cannot insert it the wrong way, and there are locking tabs that you will push in towards the center of the connector to lock this into place. In the accessory box that we looked at the beginning of this video, there are these cable management clips, and these are intended to hold this large cable into place. They will simply slip over top of the cable and then snap into place at the back of the rear pillar. They'll snap right into the extrusion slots. You just got to push pretty hard to get them into place, but they will snap in, and this is going to prevent that cable from getting caught up on the Z carriage. And since we're at the back of the machine, this is the perfect time now to make adjustments to the V-wheels on the Z carriage. So the V-wheels that are biased towards the front of the machine, those are basically idlers. They're not on eccentric nuts. The 4 wheel wheels at the back of the machine, those are on eccentric nuts, and they can be adjusted using a 10mm wrench, which was included with the machine. Now what you want to do is you want to be trying to roll the front wheels while making adjustments to the rear wheels. And when you start making the adjustments to the rear wheels, you'll notice that the front wheels stop slipping, and then you can check the rear wheels and make sure they're not slipping. The idea here is that you want all of the wheels to be in contact with the aluminum extrusion, but you don't want them so tight that it's causing too much friction. So you want the whole assembly to roll nice and smooth without too much friction, but with no play in any of the V-wheels. And once you find that sweet spot, then you're going to want to tighten down the locking nuts to lock the position into place. Make sure your eccentric nuts do not spin while you're tightening down the lock nuts, so you can either hold them in place or just check that they didn't move and that none of your V-wheels are freewheeling, that they all are still in contact with the aluminum extrusion. We're almost ready to turn the printer on and start leveling the print bed, but what I like to do is I like to play it safe to prevent a nozzle crash right from the start, and I take all of the bed leveling screws and I tighten them all the way down. Then look on top of your print bed and look towards the back, and you'll see this little adjustment knob. So this comes into contact with your Z limit switch. What I like to do here is I like to unthread it a bit, and there's also another knob on the bottom that locks it into place, but we're just going to unthread that and raise it up a little bit. What this is going to do is this is going to give us ample amount of space between the nozzle and the print bed when we first turn the printer on and we start trying to home the Z axis, so that we do not get that nozzle crash right away. So with the printer on, you can head into the settings and you go over to move, and now you can home all of your axes. As you'd expect, all of the axes are homed against their respective limit switches, and then the print head moves to the middle of the print bed. The Z axis moves up as well, and there should be now ample amount of space between the nozzle and the print bed such that you do not get a nozzle crash right away. Now, if your nozzle is way too far from the print bed such that you think you would have to unscrew those bed leveling screws too much to raise the print bed up, you can always come back to that little adjustment knob and tighten that down and move that down a little bit further, then rehome your Z axis again so that this will bring the print bed closer to the nozzle. Now, before getting into the bed leveling, what I like to do is I like to preheat it. So in the temperature settings, I can set the bed temperature to 55 degrees Celsius, which is more or less what I'd be using while I'm printing regular PLA. Now, the reason for doing this is that things expand and contract as they heat up and cool down. And so by heating the print bed up and then leveling the bed, it's a better representation of what the bed position will be like when I'm printing. And therefore, the bed leveling will be more accurate. Now that the nozzle is within a reasonable distance to the print bed, we can go to the leveling feature. And this is going to bring up a screen where you can choose automatic leveling or auxiliary leveling. Now, this printer does not come with auto bed leveling despite the price tag, which is a little bit surprising. So you're going to hit that auxiliary leveling, and this is just manual print bed leveling. So you have 4 options, 4 points essentially on the print bed, which correspond to points that the nozzle will travel to, such that they will be directly under those adjustment screws. And so by pressing either 1, 2, 3, or 4, the print bed will raise itself up to the point where it hits the Z0 end stop, and now you can start making adjustments with those knobs. And so if you've been in the 3D printing game for a while, this is really nothing new, and you're going to be using the tried, tested, and true paper leveling method. And so go grab a piece of regular white printer paper, and on this particular machine, I like to cut the piece of paper into a long, thin strip. Because on the Ender 7, it's a bit of an awkward platform to work around. There's a lot of obstructions when the build plate is at the Z0 position, and so a very long, thin piece of paper makes it a little easier to reach the nozzle, especially in those rear positions. What I like to aim for here is a nice light drag between that piece of paper and the nozzle. You definitely don't want a tight fit where the nozzle is pressing down on the piece of paper so hard that you're ripping it or it's stuck and you can't get it out. It should be a nice light drag. What you also find is that you are going to have to go around several times to get the position of the nozzle with respect to the print bed consistent. So if you work your way around positions 1 through 4 once, and then you go back to position 1 and slip that piece of paper between the nozzle and the print bed, what you'll likely find is that it's either going to be too tight or too loose. Go around several times until you have a consistent distance between the nozzle and the print bed. Then when you have all 4 corners consistent, hit the center home position and check the center of the bed with the piece of paper. Now we're ready to load some filament into the machine, and you can just put your spool on the spool holder, clip the end of your filament, and start inserting it through the bottom of the filament runout detector. Now you're going to want to straighten out the end of your filament so that it will fit directly up and into the extruder assembly. You can definitely see it with your eye, so take a look underneath to make sure you're guiding it into the hole properly. You're going to squeeze down onto the extruder lever, and that's going to release tension on the extruder and allow you to manually push the filament up and into the Bowden tube. I prefer to manually feed the filament all the way through the Bowden tube to the print head. I just find it's faster than letting the extruder do it, but that's up to you. Now when you're squeezing down on the extruder lever, if you find that it's really loose, then you may need to tighten the screw on top of the extruder lever. You'll see it, and that's right where my forefinger is on my right hand side. So that can adjust the tension on the extruder. Now, if you're new to 3D printing and you've never done this before, it's hard to explain what the proper amount of tension is, but you'll notice it in your prints. If you have a lot of under extrusion and gaps in your print, you might want to check that screw to make sure that you have enough tension that the filament is properly being gripped by the extruder. Now that I have the filament pushed all the way to the hot end, I can head back into the temperature settings, and I'm going to set the nozzle temperature to about 200 degrees Celsius so we can start melting some plastic and feeding it right up to the nozzle. On the touchscreen, there's a button called Refuel. That's the button you're going to want to press in order to tell the machine how much plastic to extrude to prime the nozzle. Once the hot end reaches 200 degrees, I'm going to punch in 40 millimeters to tell the machine to feed 40 millimeters of filament through the hot end to prime it. Shortly thereafter, you should see some filament has come out of the nozzle, and now you know your nozzle has been primed. Now we're almost ready to print, but we need to slice some files, and to slice files, we need a slicer. Now, I'm not a big fan of the skinned Cura slicer that comes with the USB stick with the Creality printers. I like using Prusa Slicer. Prusa Slicer has a pre-built profile for the Ender 7, but I found that I needed to make some changes to it, and some of those changes included the Start G code. I'll try and include a version of my Start G code either in the video description down below or in the comment section, wherever it will allow me to put the Start G code, so you can use the same thing for your Ender 7. I find that it works better than the one that came with the Creality Ender 7 preset in Prusa Slicer. And the other thing that I modified here were some of the machine limits. Now, the Ender 7 is supposed to be a machine built for speed. Now, if you've watched some of the other reviews of this printer on YouTube, you'll find that it doesn't really go all that fast unless you're printing a really big part. Because the printer needs a lot of runway with the low acceleration values that it comes with from the factory in order to get up to those speeds. So in this sense here, I've modified some of those acceleration values, and you'll see at the top I have it emit to G code. So it should take on these new acceleration and jerk values upon the start of every single print. Within the extruder settings, one of the other parameters I changed was the retraction length. I bumped that up to about 6 millimeters. I was finding that with a lot of prints, I was getting a little too much stringing, and so I needed to bump up the retraction. The retraction speed and de-retraction speed I left the same, did not touch those. Moving over to the filament settings, one other thing I noticed about this machine was that I did not have to set the nozzle temperature too high. If it was set too high for regular PLA, there'd be too much stringing. So 200 for the first layer, 195 for all other layers was good, and the print bed at 60 degrees was perfect for first layer adhesion, and then when the print bed cooled down, it would easily release the prints. In the advanced settings, one other thing to watch out for is the max volumetric speed. Bump that up to about 15 millimeters cubed per second. The printer is advertised as being able to print quite quick with a lot of throughput, and so you don't want this value too low, and that's going to restrict how fast the slicer is going to allow you to print. So bump that up to 15 and play around with that a little bit so that it's not a limiting factor. Now in the print settings, I like to align my seams. The infill settings, it's more or less dependent on what the part is being used for, so that's not really important here. Skirt and brims, not something I typically use, especially since you're priming the nozzle in the start G code anyways for the skirt. Support material, again, this is going to depend on what you're printing. The speed settings I have set to about 100 millimeters per second for the perimeters. External perimeters are 75% of that, so they should be going at about 75 millimeters per second. I found that it was a good balance between speed and print quality. Infill I got set to 125 millimeters per second. I know Creality advertises something like 250 millimeters per second, but again, you're never seeing that speed anyways unless it's a really big print. So right now it's set to 125, and my first layer speed is a pretty conservative 20 millimeters per second to make sure that I get good first layer adhesion. One of the other parameters that I did change here was the overlap. I believe I bumped that up a little bit to 35%, and that way I'm not seeing any gaps between the perimeter walls and my infill. And so to come up with all of those parameters and values in the slicer, I had to obviously do a whole bunch of testing and tuning for you guys so that you guys could get those exact same settings and get your Ender 7 dialed in exactly the same. Now I printed things, of course, like the classic benchy, as well as some other parts that I normally print on a whole bunch of my other machines to benchmark one machine against another to make sure that the parts come out dimensionally accurate, as well as the just overall quality is something that's acceptable and desirable. We'll start taking a look at some prints, and I'll just sort of monologue my way through my observations of the prints and the printer itself. The Ender 7 is marketed for speed, and it does seem like it could be a fast printer with the CoreXY motion system, the large stepper motors driving the XY gantry with the really large drivers that I showed you guys earlier in the electronics housing at the bottom. However, in typical Creality fashion, it kind of seems like they tend to overlook some details, and those were the firmware settings where it's really not allowing the machine to achieve its full potential with the very low acceleration settings. Now, like I said, I did try and play around with them and bump them up. I did get the prints to go a bit faster, and I did see some higher speeds and lower print times, which was good, and not so much at the sacrifice of print quality. So you can see some of the parts that I did print here in a purple PLA, and they turned out fairly nice. However, with the printer as is, don't expect to see those advertised 250 millimeter per second prints. You're definitely not going to be getting that on your prints. You're not going to be printing speed benchies or anything like that out of the box. Like I said, you can change some of the firmware settings and you can definitely speed the printer up a little bit, but don't get your hopes up for super fast printing out of the box. That being said, I think the printer overall has a higher than normal quality of construction for a Creality printer. It is on the more expensive end, so you would hope to expect that, but it does seem like overall a solid printer. There are a few small details that I still am sort of scratching my head about, which again is sort of typical for some Creality machines, and namely that is the Z motion system. I just feel like there's too many parts in there and it's a bit of a mishmash in terms of design. I think they could have done a better job on that. The cantilevered bed is a little bit wobbly and it definitely sags. So when you go to level the print bed, the 2 bed leveling screws at the front of the machine, because the whole print bed is sagging, you really have to unscrew those a lot more than the 2 rear adjustment screws. And if you're not careful with where you put the Z end stop, you could run out of adjustment on those 2 front knobs, and you may not be able to get your bed leveled without making an adjustment to that front, or rather rear knob that hits the Z end stop. Despite some of these minor design issues, overall, again, it does print really well. And here's a closer look at that benchy that I showed you earlier. The stack up at the top is crisp and clean. The hull looks nice. The first layers on this printer, despite, like I said, the weird sort of design of the Z motion system, first layers on this printer come out excellent. And even the print surface, although it looks like the typical Creality glass, there is something slightly different about it. It's more of a matte finish. It feels a little bit more like a chalkboard, and the prints stick much better than the Creality glass on any other Creality machine that I've used. Corners come out fairly crisp. Again, if you start jacking up the acceleration a little bit too much, then you're going to start to see those bulging corners. I think this printer would benefit from something like linear advance or some sort of pressure advance setting. And I think in the future what I'm going to do with this machine is try and get clipper running on it, and that should address some of those bulging corners at higher speeds. Top layers look exceptional. They're very consistent, even with the Bowden tube setup, so I was quite impressed with that. Part cooling is decent too. Overhangs and bridges come out fairly nice. You've seen those on some of the other parts I previously showed. The only one issue with this printer that seems to be very hard to tune and address is that with certain filaments, you still get some very small stringing, and it's just very light wisps. I've played around with all the retraction and temperature settings, but you still seem to get very, very light wisping with some filament. It's easy to remove in post-process, but it's worth mentioning. So thanks for watching through to the end of this video, and I want to address what I talked about at the beginning of the video when I said I've already done a few modifications to this printer. Now, normally when I do reviews of printers, I spend months at a time printing endlessly to make sure that I give you guys a real and honest opinion of the printer. Now, in this particular case, the purpose of me owning this printer is not so much to just do a review of it in its basic form, but to bring you guys some content on this printer so that it could achieve its full potential. I think there's a lot of potential in this printer, and I don't think it's being realized just yet. So when we did the assembly, one of the things that I pointed out was that the bed is supported on a cantilevered platform that's supported on the rear extrusion of this printer. And that's using those V-wheels. And so the bed support just sags a little bit at the front, and that's something I pointed out earlier in this video. Now, the modifications that you see here right now are sort of stage 1 of what I want to do to this printer, and I want to see this printer realize its full potential with its speed, and that means cranking up things like obviously speed and acceleration values in the firmware, and that's going to cause the printer to shake around quite a bit. And so that bed needs to be supported very, very solid. So I'm working on prototyping a bed support system that uses linear rods and bearings in order to achieve this. And I'm gonna be making a kit available for this printer soon. So there's gonna be a new video coming out shortly with this modification, how to do it and where to get the parts. So keep an eye out for that. And that's just a very brief explanation as to why the printer looks the way it does already. So keep an eye out for the next video. Please hit that like button and subscribe. Thanks for watching.